Okay, fantastic. Okay, so yeah, hello everyone. It's a pleasure to be invited to Lido Node Operator Community event, and yeah, I see that presentation so far we are quick. So sorry, so likely I'll be quick. And if you have any question during the presentation, yeah, you can interrupt me and we can discuss it. Okay, so the presentation is called Boosting Ethereum Consensus Client Diversity with Grandine. And I'm Saulius from Grandine team. Okay, so uh, here we will just repeat what we already know is that client diversity matters. And the key thing is that Ethereum relies on multiple clients to stay resilient. So essentially, if we want a resilient network, Ethereum network, it's the main thing that we can do is to have a really good client diversity. And at the moment, at least on the consensus client side, we likely don't have a super majority client, which is very good. And likely on EL side, also there is no super majority client, which is very good because this means that sorry, because this means that a single bug in the supermajority client cannot essentially break the chain and make a disaster. So this part, the very worst case scenario, likely solved. However, we still have a quite big issue with the fact that some of the clients are taking more than 1/3 of the share, and this means that a bug in that client may disrupt finality or have some other impacts on the network. And yeah, obviously the Ethereum went with this multi-client approach, which so far, as we see, and well, Ethereum didn't have a very bad incident. The mainnet didn't have a very bad incident for a very long time, and that, at least in my belief, that is mainly because there is this client diversity, which is really a great thing, as I mentioned. And yeah, and the last thing is that if we see the Lido node operators, we really see quite good diversity. So I'm really happy that Lido community really cares about diversity, and it's not the situation where the majority of the node operators are running sorry, the same client. So we are on quite good track. Yeah, and for the Grandine history, the development, as when told it, the development is already for quite a few years, and we started development in 2019, and then in 2021 we released the first binary. And after the release, we saw that there is some traction and people are interested in the client because our main focus was really a performance thing, and there is always some users that are really interested in the performance, and we saw that from the very first binary release. Sorry, and in 2024 we open sourced the client, and then we got a few audits completed, and we got integrated into the EF's fuzzing infrastructure, and so far essentially no audits and no fuzzing and no other tooling found anything serious. So far, there were some very minor stuff that doesn't affect the client performance or reliability. But yeah, we fixed those small things. So overall, we got a really solid client, and so far we didn't do any kind of targeted marketing or so. And organically, we have around a couple or so percentages of the validator share. So that's a quick history. So sorry, the reasons why you should consider Grandina. So one thing is that it's quite modern consensus client written in Rust. So we have less, and the entire code base is smaller, and we have a less of technical depth in the code base because the client started later in the process in the development of the beacon chain clients, and we just didn't have a lot we don't have that much of changes in the code base as the other clients. So obviously the technical depth is better than at least some of the clients. Then the client from the beginning was optimized for the best performance, and at the beginning we mostly optimized it for the fast state transition function. So the block importing was the fastest among the clients, as it was discovered by Mega Labs performance testing comparison. And another interesting thing that we highly optimize the client to be used via Beacon Beacon API, and especially for the end clients such as Vouch. And this means that on average, of course, it's not always because in such a distributed network, it's not possible to have to always get a perfect result. But on average, we observe that our client is doing better both in terms of the response times, as for example, like beacon block production time. So we see that on average we are very competitive with other clients, and often we outperform if we look at the metrics of Pouch. Okay, so then yeah, the other interesting aspect that the whole client is built on the three states from the very beginning. So some other clients like Lighthouse, they moved to this approach after their entire client was built and used for several years. So we have this design, which we believe is the right design, because eventually the beacon state became really large, which is in SSD, it's a few hundred of megabytes, and now we have over than 1 million of validators. So it's a much bigger success than I think everyone thought for the beacon chain. Okay, that's the station, and the three states is a very good sorry, very good approach because it allows to store a lot of states in memory, and especially this helps when the network is not in the best shape, and you need to access different states on fly without the delay or with minimal delay. And of course, we are focused on security, performance, and maintainability. And yet, this is an open source project that we actively develop, and we got some external contributors. So yeah, check the GitHub repository for that. Okay, so as Sven already introduced, we just received the Lido Lego grant, which essentially the goal of the grant is to help boost the diversity of consensus layer clients, because the goal is really so now we see that some of the clients are taking more than 1/3 of the share, and the bug in that client would disrupt the finality. And yeah, the goal would be to over like a half or year or a year to get a Grandina share of the validator set, to increase the share to maybe 5 or 10%. And this would be really a solution to this issue we have, because I mean, the clients that are running for more than one third of the share, at least based on the data that is available, and the data is not very reliable, but at least it's something to think about. Uh, Sorry, it's uh, it's not that huge issue that cannot be solved. I mean, we just need to shave off a few percent of these most popular clients, and then we would be able to switch to the mode where no client has more than one third of the share, and that's the real desire that we have, and hopefully this grant will help to achieve that. So the exact steps that we are thinking now that could help to achieve that is essentially working directly with node operators to support them and to ease the migration to Grandine. And I think yeah, if some operators are in this call, or you know some operators that would be interested to increase the client diversity, then let us know. It's very easy now, because most of the operators are running quite sophisticated setups that relies on the beacon API, and Grandine implements the beacon API. So you just need, especially if you are using something like Vouch, you just need to add Grandine to the mix of your beacon nodes, and that's all. So very easy step, and a lot of benefit to the network. Then the good thing that as we are focusing now on including the market share, we are quite open to implement some specific stuff that hopefully would be helpful for the future deployments. But for example, if you have some specific needs for the client, which likely has potential to be a benefit for the rest of the network, we would be open to implement your requests. So this is something that it's not very easy to get with the other clients, especially the most popular clients, as they are more focused on the work that they already have. Then obviously the onboarding documentation and the community support. Then some additional testing, interoperability testing between the other clients and other validator clients and so on. So we would like to increase the compatibility with the other parts of the ecosystem, even though now we are quite compatible with the rest of the ecosystem, and obviously various other client diversity initiatives here. Okay, so yeah, and the last content that may be interested to some of you, but not directly interested to node operators, that we are doing multiple. We have a lot of research going on, and one thing is that we are building a REST KZG library, which is a high performance KZG library for blob scaling, which is at least in some aspects faster than the alternative KZG libraries, and the speed here directly contributed to things like, for example, blob throughput. So this is something that we think gives value to the ecosystem. And yeah, if you're interested in these in such projects, you can check it. And another interesting project that we are working on is a different chain standardification project, which essentially allows to have proofs for beacon chain state transition function. And so far, we achieved proving for a smaller Pectra DevNet state that consists of 100K of validators. However, the mainnet state transition function proving is still tricky for the currently available ZKVMs, which is SP1 and Resi0. Sorry, these two of ZKVMs are kind of most mature and at least in the ecosystem recognized as the most production ready ZKVMs. So, but we are pushing this, and ZKVMs are getting faster and faster, like every month, I would say. So I think we are not very far away from beacon chain state transition function proving, which would enable some new interesting products in the staking ecosystem. So that's all. It was a quick presentation. If somebody has some questions, I'm happy to answer it.
Yeah, there's some questions in the chat. I can read them out in a minute, but I wanted to ask you about the tree states because you did mention them. So let's get into the detail right away. It's actually pretty cool, is that these tree states. Now, I'm not a coder, I'm not into the protocol that much, but how do the tree states that you've implemented, how does that differ from how other clients do it?
Yeah, so one thing that some of the clients even didn't have this approach. So the three states, I can maybe do a very quick intro that the key idea is that the state takes a lot of memory now. So I mean, even if in compressed mode in SSD format on the mainnet, it's few hundred megabytes. So in expanded form on the runtime, it's something like a gigabytes, you know. So and for every slot, you have state. Okay. The problem is that if you have if the network is running really well and there is no any side forks or whatever, then it's unlikely that you need a lot of these states in memory because you just need just a few states and it's not a problem. However, uh, for a bit, you cannot you cannot optimize the client for the very healthy network. You need to optimize the client to run not well in a very healthy network like the mainnet, like the Ethereum mainnet, but at the same time, you need to be prepared for the worst case scenario. For example, for the Holesky incident, where I think most of the clients had serious issues because most of them were not prepared for such a deep non-finality and deep forks and so on. So one of the ways to solve it or partially solve it is to use a tree of states. And the key idea is that the states do not change that much from slot to slot. Okay, so this gives you a good idea that maybe it's possible to only store the difference between the div between the states, right? So, and in this case, you save a huge amount of memory and you can solve a huge amount of memory issues essentially. You just have you can think that you have a kind of a main state and then you have diffs from that state in the memory. And the exact implementations of this, I think it differs from client to client, but the concept is more or less the same. So you just use so-called structural sharing, where the idea is that every data that repeats across the states, it is not actually doubled in the memory. It's not copied in the memory. Instead, the reference to the single point is used. So yeah, so this is how it's achieved. Essentially, it just avoids a copying memory. That's all.
Yeah, that sounds really interesting. Like, is this something
Yeah.
that other clients could adopt as well, or does that only work when you design it from scratch in this way, like you did?
So the other clients, I think now a lot of clients has this approach, really. Maybe not all, I don't know, because when we build a client, we tend to not look too much at the other clients because this kind of conflicts with the diversity thing, and diversity thing essentially says that if you want to make a diverse ecosystem of clients, so when you build a client, you do not want to look at the other client, because once you look at the other client, it will become kind of you will copy those ideas, even if even unintentionally, you know. So I think this is the approach that other clients are taking, and they just have their own implementation of essentially of the same concept of the same thing.
That's really interesting. Take
Yeah,
that makes total sense actually.
yeah,
I got a question from Dima here. So for real life node operators, for example, home stakers, would they be able to see a difference in performance on a DApp node or some other home staking device?
yeah. So the whole staking is quite interesting thing. So the client that we are building, we always look for the optimizations, and essentially it means that the client is helpful for both local node operators and like home stakers, and also for some other for larger staking operators. I mean, as long as you have a client that is a high performance client, it works both for the home stakers and for the professional operators that are running a large amount per machine and so on. So this is one thing. The another thing is quite interesting, or the idea, let's say. So the home staking, I don't know, maybe this is just a rumor, but seems that the home staking is not getting, let's say, more popular these days. So I don't think that is a great thing, but that's the situation. And I would say we don't particularly optimize for the home stakers. I mean, there is kind of no exact intention to optimize for home stakers. However, as we are focusing on efficiency and the performance, there is a benefit both for the home stakers and the node operators. So this is one thing. The another thing what you also need to think that maybe or never mind. That I hope that this answered your question.
Yeah,
Yeah,
let me like super quickly jump in because
Yeah.
I'm a first of all, Dmitry from CSM here. Yeah, hello. I'm a big fan of client diversity and decentralization, and I was always trying to run the most like the least represented client
Yeah.
in the network. And that's how I got into our ETH or REF or the client execution layer client developed by Paradigm.
Yeah.
And apparently, they were saying basically the same things as you do. So they were saying that, hey, we are super optimized in terms of performance, yada, yada, yada. However,
Yeah.
it turned out at the early stages of RE, which is not the case now, but at the early stages, it turned out that RE was performing like not great at all on a home staking hardware. even though my DApp node is the latest DApp node, it has a pretty decent CPU, 32 gigs of RAM, and pretty fast SSD. Still, our ETH was not performing great, even though it was claimed that it was super optimized. And by the way, it's also written in Rust. So my
Yeah.
question is, have you guys tested your client on a home grade machine? And should I even consider trying to switch from my beloved Lodestar to this brand new super optimized client that you are telling us today?
Yeah, so we are running a large amount of validators on a very large computers that we have in the office. So it's like a 12 years old CPUs with 4 cores or something like that, and 8 GB of RAM. So we are really confident that that the client runs on the low, say, low resource machines or so. However, given that, I mean, I just wanted to say that that we particularly do not optimize for the a very a very unpowerful machines, for example, a Raspberry Pi or so. We actually did that. We did run the client on Raspberry Pi back then, and it was maybe 4 GB machine or so, and it was running on the mainnet. However, at some point we figured out that it's enough to run on like a 12 years old CPU and 8 GB of RAM, and likely it represents the minimal, let's say, minimal hardware that some home staker would do. So yeah. So the answer is yes. We are doing really well on the low resource machine. Is one thing. Another thing, the ref case is completely different from our case. So ref was developed. I mean, we are developing since 2019, and this is, we just didn't do a lot of marketing, and we just open sourced last year or so. But the client itself is rock solid, and it's optimized for many years. And the ref is actually much newer client, and obviously they will need to go, for another few years to nail the client and to get a really good performance of that. So I think, yeah, the key difference, and maybe the key message is that if you want to have a really great client that works, including on a low resource devices, this is not something that you can do in a couple of years. It takes many years, and we are doing that since 2019. So yeah, I really suggest you to try it. And if you see that there is some issue or some underperformance, which I doubt, but if you see it on the lower grade devices, then let us know. We will be happy to try to check it and to make sure that it works on the lower, on some specific hardware where you see the issue. But as I said, we are running really a lot of testnet validators for the testnets on the very old hardware.
Got you. Thank you so much. I'll definitely give it a try sometime soon.
Thanks.
Thanks, Dima. Let's see. Saulius, you said something about home staking not being as popular as
Oh yeah.
And that blew up the internal chat here. So I'm trying to fish through that to get the questions. You're available on Grandine is available through ETH Docker, right? And also on DAppNode, I think.
Yes. It's available on ETH Docker for sure. We actually are using ETH Docker ourselves for DAppNode. Frankly speaking, I'm not sure. We need to double check it, and if it's not, we definitely need to put it there. So that could be an effort from for that part of the effort for the diversity boost grant that we just received.
Yeah, we do these stats asking our CSM operators what they're running, and that node is definitely a favorite. So a lot of
What
people
is the
visit. So
second one after that node?
I think ETH Docker.
Ah, okay, okay. And the third one?
Oh, you're asking me too much.
Maybe
We
there is
publish it.
no third one.
We publish it every quarter, but then I forget until the next one.
Oh, okay. Yeah, you can
Uh,
just drop the link because we definitely want to get on all the, let's say, on all the popular platforms as a minimum.
Oh, great. No, that's perfect. Like the ease of install, I think that's good for home stakers, and you'd be surprised of the machines they're running on. I don't think anybody's seriously running on a Raspberry Pi. That's just a meme, to be honest.
Oh,
People do it
really?
for
People are still running on Raspberry Pi?
No, they don't. They
No?
don't. Like most of them
Okay.
just have these 64 gig NOCs, like brand new out of
Yeah,
the box. So they're absolute beasts of machines in tiny packages.
exactly.
That's
Exactly. I
great.
mean, if a lot of users are using these machines, then well, very likely there is no issue with any client, I believe, because
Yeah.
it's like it's a very powerful machine.